Game design is a large and complex topic, and a multifaceted one, ranging from psychology to interior design to scripting and implementation. Understanding at least the basic workflow of making a game is important. Before we dive headlong into our game editor, we need to see where it sits in the pipeline and what we'll be doing in the different software packages we'll use. We play games to immerse ourselves in an alternate reality. This is something that every game designer and anybody associated with the making of a game needs to keep at the forefront of their mind. And it's especially important when we're deep in the technical workings of implementing a part of that game. It's very rare to walk down the street and encounter a dragon, for example. But we play games because we'd like to have exactly that experience. We're in a street, and suddenly there's a dragon, and we have to decide what to do. We crave that luxury of often artificial fear, or the ability to do something that we cannot do readily in our daily lives without fear of the consequences. In that same vein, not many of us are elite special forces soldiers tasked with repelling the invading alien army, but we play games for precisely that purpose. Even simulation games or serious games exist to immerse the player in a version of a reality. There are training sims, for example, for planes. It's very difficult to take a novice flyer and put him or her in a cockpit of a multi-million-dollar plane. But in a training sim, we can get a lot of experience in flying that plane and understanding how the controls behave and seeing the consequences of our actions. We as game designers have to keep this in our mind, that things need to be seamlessly, obviously right, and not break the illusion of that immersion in that reality. Unity is a versatile game authoring tool. We'll use it in many facets to make our game. It's a game editor, where we stitch together multiple levels and other components to make a full-fledged game. It's also a level editor, allowing us to bring in and place assets and add interactivity, making the actual place that the player will play. It's a game engine, and this is actually the software that drives the game the player is playing. That when they're seeing the graphics up on screen, Unity is pushing that out and driving it in whatever platform they're using. And finally, it's an authoring tool. Coupled with MonoDevelop, which comes with it, we have powerful scripting available, allowing us not only to add interactivity, but craft whatever it is we need to make our game, well, fun to play. The typical game design workflow will vary from studio to studio. Every different company or batch of designers has their own particular workflow that they like, that they feel gives them the best art and the best implementation. We'll create assets in a 3D modeling package. For example, we'll use Autodesk Maya, Autodesk 3ds Max, Pixelogic ZBrush, Autodesk Mudbox, or any number of other applications for the actual production of our assets. These packages have full-fledged modeling and unwrapping features, where we're not only modeling the polygons as we want them, but telling the texture how to flow around that object, and adding in as much detail as we feel we need to see in our game. We'll also see our 2D drawing programs come into play, such as Adobe Photoshop and Illustrator. These will allow us to craft textures, a fundamental and important part of gaming. These textures add richness and realism, as we're constrained in how much we can push around in real time in polygons. And so seeing what we think is the full detail of our world provided by the texture is of utmost importance. We'll implement our assets then in Unity. We'll import, place, and add materials to our models that we've brought in. We'll also add animation, interactivity, and scripts to these assets, transforming it from simply a navigable environment to a place we can interact with and affect our world. Unity supports a number of scripting languages. We can work in C#, JavaScript, and Boo, which is a Python variant. This gives us a lot of flexibility. Rather than using a proprietary code, we're using a code that is common knowledge. There are a tremendous amount of resources available for these scripting languages, and this affords us the flexibility not only in how we implement our objects in Unity, but to custom craft whatever tools we feel we need to make this game more fun to play. With this understanding of our process, we can jump in and start to make our game and see where we really sit in our world.